Welcome back to Calculus Universalis, and today we're diving into Unit 5, Applications of Derivatives, starting with how to interpret derivatives in real-life situations. Whether it's speed, population growth, or cost per item, derivatives tell us how fast things change. Let's break that down, then walk through 3 real-step AP-style problems together. Let's go. So what is a derivative, really? Mathematically, it's the rate of change of a function, the slope of a tangent line at a single point. On the AP exam, you'll often be asked to explain what the derivative means in context. So let's say you have a position function, s of t, and this gives an object location in meters after t seconds. Then the derivative, s prime of t, tells you the object's velocity in meters per second. So this is velocity and position, x of t, v of t. So what you need to focus on is units. If s of t is in meters, then this is going to be in meters per second. If this is in meters per second, then this is in meters per second per second. So it's always going to be the new rate. So how do we interpret this? If s of 3 is 9, is f prime of 3 equals 10, then at t seconds, s of t is 10 meters per second. So if s of 3 is 10, then at t equals 3 seconds, the object is moving forward at 10 meters per second. Exactly. Positive derivative means that the rate is increasing. Negative means that the function is decreasing. This applies across a ton of real-world examples: population, temperature, cost, and more. Now let's try 3 problems together. Okay. Problem. So we have a position function, s of t equals 2t squared minus 3t plus 1. What is s prime of 4? And what does it represent? S prime of 4, when we plug it in, we are going to get 13. So at t equals 4 seconds, the object is moving at 13 meters per second. Now for a second example, you can pause the video and do it yourself. So if a company's cost function is c of x equals 200 plus 5x plus 0.01x squared, where x is the number of items produced, interpret c prime of 100. Okay, go ahead and pause the video. So let's take the derivative. C prime of x is 5 plus 0.02x. And then c prime of 100, when plugged in, is going to equal 7. So this means when the company is producing 100 items, the cost to produce one more item is $7. That's the marginal cost. Now for our last and third example, we're going to be going over population. So population p of x, or p of t, models the growth according to some function. If p prime of t equals 1200, p prime of where t equals 5, what does this mean? This means that at year 5, the population is increasing at a rate of 1200 people per year. Notice the units. The derivative of population is people per year. So here's what you need to remember. A derivative is a rate of change, not just a number. Always check your units. G equals rate of change, units. Make sure your interpretation matches the context. Is it distance, dollars, people, And then find and interpret, for your homework, you can find and interpret the derivative of a revenue function. Revenue. Given a graph of a function, estimate and describe the slope at any given point. And then practice AP-style FRQs involving units and verbal explanations. Thanks for watching. If this helped, like and subscribe for the next video. We're going to do particle motion next.